Let's compare cardiac muscle to skeletal muscle like your bicep. Skeletal muscle is composed of all of little tiny cylinders of skeletal muscle fibers. And each of these cylinders or fibers connects with the brain by way of a neuron, connecting at that place called the neuromuscular junction. So when you go to pick something up, one muscle fiber in your bicep contracts and it can't lift it. And so another action potential is sent from your brain to depolarize more skeletal muscle fibers. Skeletal muscle can contract again, like really quickly, 1 to 2 milliseconds later. And this is a reflection of something called the refractory period. Refractory periods of skeletal muscle are based on the time it takes the sodium and potassium channels to recover. And this quick recovery of skeletal muscle, it allows for really rapid contractions and something called tetany, which is defined as sustained, uncontrollable muscle contraction. A good example of tetany is lockjaw, which is a sustained contraction of the masseter. It is now that you should go back and familiarize yourself with action potentials from the nervous system chapter. I'm going to use terms like you already know what they mean. So if you don't know what they mean, now is your chance to stop this video and watch one of the videos on action potentials. In fact, you can even dip into the action potential mini lectures that I have listed in my Anatomy and Physiology 1 class. Now that you have reviewed things on skeletal muscle fiber, each skeletal muscle fiber needs a connection to the brain in order to contract. So it needs to meet up with a motor neuron at a neuromuscular junction. Yeah, that's not the way the cardiac muscle works. Cardiac muscle fibers, they don't need a connection to the brain. With cardiac muscle, we have pacemaker cells that spontaneously depolarize. These pacemaker cells, they share their depolarization with the surrounding cardiomyocytes. And so a connection to the brain is unnecessary. I mean, so yes, there are neurons to the brain from the heart, but we discuss them later, and they only modify. They don't set the heart rate. They modify it. So cardiomyocytes, what they do is they share their action potentials with their neighboring cells through these things called gap junctions. It's these channels that connect cytoplasm of adjacent cells, and it would allow ions to flow from one cell to the next. So if one cell depolarizes, sodium ions just flow through those gap junctions into the cell next to it. The refractory period of a cardiomyocyte is very long compared to a skeletal muscle, right? That's long. Skeletal muscle can have action potentials very quickly, right? Refractory periods are 1 to 2 milliseconds, if that. In cardiac muscle, the refractory period is 15, which is a lot more than 1 to 2, to 200. That's a really big difference. That's like the difference between 2 cents and $2 or $2 and 200. Anyway, this difference, it's created by this plateau here in the action potential of cardiomyocytes. It's not like a normal action potential. The plateau extends the refractory period, and it makes one cardiomyocyte kind of wait before it can contract again. Ah, the plateau. The plateau keeps those cardiomyocytes positively charged or depolarized for a long period, right? They stay positive. At first, you might think it's because potassium ions are not flowing out of the cell, right? Because that's what makes repolarization, is that potassium starts flowing out of the cell. They are. Potassium is flowing out of the cell. They are. However, there are calcium cations and other, well, no, there's calcium cations, we'll leave it as that, flowing into the cell. And the flow of calcium cations, and I want to point out that calcium cations each have two extra protons compared to potassium's 1 extra proton. And that's what causes this plateau. That's what keeps the cardiomyocytes positive for a longer period of time. The plateau prevents the cardiomyocyte from having another action potential right on top of the first. So basically, the plateau makes it so that a cardiac muscle fiber has to wait before it can contract again. So there's no tetany here. We don't have tetany. You can't have tetany. I mean, we'll talk about that. Drugs like digoxin can affect calcium channels. And drugs like digoxin, they can alter the plateau's duration. An overdose of digoxin produces something it's kind of like one long eternal plateau. That's what digoxin does. Along with the plateau, it causes death, right? People dying from a dig overdose, they have like one last action potential that just doesn't, it never stops.